Next problem. This problem is asking us to identify I1, I2, and I3 using the loop mesh analysis. So this is where we're going to use our loops. Go ahead and drop those in here now. So loop 1 and then loop 2. Okay. And as before, we'll just write our KVL laws out. So, and I'll say for loop 1, we'll have -10, because since we're picking a point and then walking that way with it, -10 plus v1 plus v of 3. So plus minus plus minus plus minus. Okay, so whatever terminal we're hitting with that current, and then that'll be equal to 0. Okay, and we got to remember v is equal to IR, so therefore I is equal to v over R. Which is not going to be used in this case. But anyway, so if we go through here and we rewrite these out, so -10, replacing the voltages, plus I1, V of 1 is going to be, this is V of 1, this is V of 2, and this is V of 3. This will be 10 ohms for that R1. Then we'll do plus I of 3 and 40 ohms. Okay, so it's the current that passes through the resistance. All right. If we go write our KCL law out, we'll notice that we said I1 and I2 are going to make up I3. So we can say I3 is equal to I2 plus I1. So let's go ahead and replace that. So we'll do -10 plus 10 I1 plus 40 I1 plus 40 I2 is equal to 0. And this should give us 50 I1 plus 40 I2 is equal to 10. Okay, and this will be our first equation. If we go write loop 2 is going to be -20 plus V of 2 plus V of 3. And that'll be equal to 0. And once again, V is equal to IR. So we can just come in here and say -20 plus I2 times 20 plus I3 ohms times 40 ohms. That'll be equal to 0. All right, if we go ahead and sub in our I3 is equal to I2 plus I1, we will get -20 plus 20 I2 plus 40 I1 plus 40 I2 is equal to 0. And once we combine like terms, so 40 I1 plus 60 I2 is equal to 20, and this will be our second equation. Okay, so if we want to go ahead and use our plug and chug, then we can say here, let's go ahead and solve for I1 first. So I1 or I2 first. So we'll do I1 from equation 2 is equal to 20 minus 60 I2 over 40. Okay, then we go plug that into first equation, we will get 50 times 20 minus 60 I2 over 40 plus 40 I2 is equal to 10. And if we by 4, and if we actually do 50 divided by 40, this will be 1.25. 20 minus 60 I2 plus 40 I2 is equal to 10. So this will give us 25. This will give us 75. I2 plus 40 I2, 10. So combining these like terms, we will get negative 35 I2 is equal to negative 15. And therefore I of 2 will equal 15 over 35. So I2 is equal to 0.428 amps. All right, so that's part 1. And if we continued on, all we had to do is come in here and say, we go to equation 1 and say 50 I1 plus 40, 0.428 amps is equal to 10. Therefore, 1 is going to be equal to should give us negative 0.1424 amps. All right. So what does that actually mean? So that means that we found that the currents are actually in a different order than what we originally predicted. So whereas we had I2 traveling the way that it does up here, like that, we originally had I1 going that way. But in reality, I1 is negative. It's actually going that way. And then I will do the Cramer's rule. And let's actually do it in, okay, do it in green. So if we did Cramer's rule, and we want to find I1, this would be the determinant of 10 over 20, 40, and 60 over the determinant of 50 over 40, 40 over 60. Then we will cross multiply here. And here, I'll write these equations out for you again real quick. So 50 I1 plus 40 I2 is equal to 10. And then 40 I1 plus 60I2 is equal to 20. Okay, so these are your x's, these are your y's, and these are your constants. All right, where your I1 and I2 are your unknowns. Okay, so if we multiply these out, 10 times 60 minus 40 times 20 over 50 times 60 minus 40 times 40 negative 200 over 1400, which should give us negative 0.1424 amps. All right, so that's I1 if you did Cramer's rule. And then if we go over to I2, determinant of 50, 40, 10, 20 over determinant 50, 40, 40, and then 60. So this will be 50 times 20 minus 10 times 40. This will be 50 times 60 minus 40 times 40. So we'll get 600 over 1400. And notice that that 1400 is the same in both. It's just the same equation. And that should give you 0.428 amps for I of 2. All right, so either way works. And then for I of 3, so I of 3 is just equal to I1 plus I2. So therefore, I of 3 is equal to 0.286 amps. And actually, if we go and look back at our previous problem, would you look at that? It's the same answer. So it's just two different analysis techniques to find the same value. It's up to you to figure out which one you like and which one's easier to work with. All right, I'll see you in the next problem.